This is not a deep dive into how, Bayesian, methodologies work, but this is a consideration of like what, as engineers, business people, product people, designers, how should we be thinking about AI a little bit? And an hour is not nearly enough time to cover all of this stuff. There's a lot of stuff here. We might get through it all. We might not. We'll see. But I timed it out. Well, let's hope for the best. As mentioned, founder of Gravity AI. I've been building this platform for roughly 3.5 years. I know many of you who on the call that from my time when I was at Boston Consulting Group, working as a lead product manager on an AI product. And then I ultimately took that AI product and worked with my client State Street for a couple of years. I told them I'd give them 2 years, and I gave them 2 years to the day. I keep waiting for someone to tell me that that headshot is way too old. And, my time at BCG and State Street aged me between that headshot and now, and it's not valid anymore. But you know what? I'm going to keep using it. I'm keeping it as long as I can. I'm kind of curious, let's set a baseline. Feel free to come off mute or drop in the chat. Like, what do we mean by AI? What comes to mind when you all think about the term artificial intelligence? I would give it a solid 15 count in my head. Yes, robots, robotics, Tesla, neural nets. Yep. How we actually train computers. Yeah, training is a key component of how we think about it. Great definition there from Gabrielle. Super fancy AF. But you said if else, but yes. Yeah, awesome. Yeah, voice assistants. Yeah, super, super great. Trying to make a computer that can learn. Yeah. So I would say that there's a nomenclature problem in this industry. Artificial intelligence, machine learning, data science, models, algorithms. There's there's not a whole lot of, consensus on how we define things and how they fit into other things. Although that consensus is forming a little bit faster. There's a running joke that when you're talking to a venture capitalist, it's AI. When you're talking to a CEO, it's machine learning. When you're talking to somebody who knows what they're doing, it's a basic hierarchical model. And it is very situational. But drop in a chat, like, who first coined, when was this coined, the term artificial intelligence? What do you think? A, B, C, or D? Got some D's. Oh, we got a normal distribution happening. Speaking of statistics. Some B's, some C's. D would be cool. Well, not that far off. It was coined by John McCarthy in 56. 56. He believed that, we, even at that time, that we would be able to have computers that could think like human beings. And for a number of years, a couple decades, this problem was being worked on pretty heavily. And then I want to say it was the late 70s, maybe early 80s, where we have something called the AI winter, where this concept of artificial intelligence just had very little attention paid to it. It was the realm of quacks for a little while there. And obviously, it made quite a resurgence with the increase in computing power and open source technologies. But this term has been around for a long time. John McCarthy is the man, by the way. He coined another term that I know many of you use regularly or have had to think about. If you know it, drop it in the chat. Otherwise, I'll give it away. Or you might be feverishly Googling it. Good guess. It's the bit. He coined the term the bit. What a like 2 huge terms from this guy. It's amazing. We do indeed have a nomenclature problem, but generally speaking, AI is the theory which is attempting to get human beings to perform human level tasks. So there's some consensus around the idea that it's a broader encompassing term. that would encompass machine learning, encompass the term data science model, all of the things in between. But depending on who you ask, it might need to also include like the fact that it can perform a true function, whether that function is extremely narrow, as is most of the case with AI, or something more broad, which we don't experience a whole lot of. Machine learning is an approach within this discipline of data science and AI, where we are, as many of you mentioned in the chat, using data to teach machines. We're essentially taking data as practice material to allow a machine to practice very quickly at usually a single task. It can do one thing really well, like play chess or play Go or detect a road sign. But if you ask that same machine learning model that will dominate a human being playing chess, if what 1 + 1 is, it has no idea, right? It cannot expand outside of those bounds. So a couple things that we talked about with AI, right, come to mind: Tesla, robotics. What about machine learning problems? Like, what kind of problems can we solve with machine learning? I mentioned a couple examples. Categorization, yeah. Categorization, classification of things. Recommendation models, yep, like Netflix is a recommendation model. Amazon famously has their product recommendation model. What else? Route optimization, yeah. Getting from point A to point B the fastest. I have a route optimization model on gravity-ai.com. That's gravity-ai.com for any of you app developers who need something like that. Protein folding, yes. Protein folding, for those of you who don't know, was a machine learning problem used to come up with new ways of folding proteins for the purposes of like drug discovery and other medical treatments. It's made huge leaps into the medical field. Computer vision, yeah, totally. Allowing a computer to detect things. Yeah, speech recognition, these are great. Yeah, perfect. I love it. This is probably not fully all-encompassing, but we do think about machine learning into several different categories. 90%, and I don't have a source on this, but I have a strong gut feeling. I'm pretty sure I've seen this stat somewhere. 90% of machine learning models will fall within the supervised learning category. So this is where we'll start. Supervised learning is when you have a data set that has had human intervention in it, where perhaps you've got pictures of cats and dogs, and you have 10,000 images of both cats and dogs, and a human has gone through and said, this image is a cat, this image is a dog. And based off of that prior historical information of someone supervising that information, those images get fed into a machine learning model, and it's able to use that information to process it and spit out a prediction of whether or not an image you give it is a cat or a dog. So this does require, obviously human labeling as part of the process. This is very common in things like fraud detection, right? Is this a fraudulent transaction or not? And we'll use a huge data set to be able to predict fraud in the future. But other, aspects that we are probably very familiar with that we see it in is if you've ever liked thumbs up something or thumbs down something, you're training that model by giving it a thumbs up or a thumbs down based off of your preferences. And it's essentially creating a recommendation engine at that point. So if we had Spotify running, if I like a song, it'll feed me more things like that that other people have liked. On the unsupervised learning, this is the feeding of very large data sets into a unsupervised learning model for trend analysis, or identifying essentially patterns within that data that might be difficult for a human to detect. It doesn't require that data to have labels on it, as is the case in supervised learning. A great example is customer segmentation. You feed it a bunch of CRM data. This might include like, company of somebody in your CRM, might include their title. It might include demographic and psychographic characteristics about them. It might include their behavior patterns while interacting with your site. And it looks for commonalities between those individuals and then can segment them into clusters. On the top side of that, under dimensionality reduction, this is like when we think of like data compression algorithms. This is how this is the field with it, like data compression comes. So if you've ever had a compressed video, there's a model making a decision about what to remove, what frames essentially to remove from that video to make it, the least interrupted experience. There's something called feature elicitation here, which is looking for the trends and patterns within a data set, which we would call features that most define that data set. So, what are the things in a loan approval model that might define the data set that would indicate whether someone should or should not be approved for a loan? And then reinforcement learning, also sometimes referred to as GANs, generative adversarial networks. You don't see a whole lot of this. It makes up a very small percentage of what's happening within the space now, but a very cool percentage. In short, you pit different AI against each other, and it evolves over time based off of which one of those won that scenario or got closer to a goal. You're typically running millions of simulations in a simulated universe to see which one of these simulations pans out better than the other. And it's a robot battle. There's a great Google while you're on YouTube, search for AI learns how to walk. And you'll see this generation after generation of a little stick figure trying to get across the screen. And it's going to come up with ways to get across the screen that we never would have thought of, because that's its goal, is to get across the screen. But it's not going to walk normally, I'll tell you that, spoiler alert. But this is actually, this does have very practical applications. Like this is, since it's working in a simulated universe, essentially, that's meant to resemble the real world. This is really good for like navigation, right? So this is one aspect of how Tesla's autopilot might be trained. Questions or thoughts on these different categories? Anything you want to dive into more? Feel free to drop them into the chat. So, yes, where would word sentiment analysis fall? Great question. That would fall most certainly within the supervised machine learning category, because we do have to label sentiment. Although we do have some emotion detection models on my platform that are a combination of unsupervised and supervised machine learning, which is looking for patterns in the way that people are speaking, and then using human intervention to better label those. Almost every major model that's in some sort of production environment today is not a standalone model. It's a series of models, what we would call like an ensemble model that uses a combination of multiple techniques out of what you see here. Typically a combination of unsupervised and supervised machine learning. What is the on-ramp when companies start typically? Oh, yeah. Companies like mine are out there to make that faster. Like we're a production-ready like model marketplace. But there's different levels of maturity. And as we're going to talk about here shortly, having the data necessary to build models is one of the main kind of barriers for entry in the space. But really, it starts with just having a data engineering team, a problem that you've identified, and a data scientist that need to work on it. We can come back to that a little bit. I'll address that a little bit more later on. So this is kind of a classic example of why machine learning is important and why machine learning, right? Type into chat for me or come off mute. Like, feel free to come off mute. There aren't too many of us. What are some rules that you would create to distinguish a chair from not a chair? Some of you have kids, I know. If you're trying to teach your kid what a chair is versus not a chair, what rules would you tell them? Alan, yeah, something with 4 pegs on the bottom, right?
Generally like lower than waist height.
Typically lower than waist height, you know, can sit on it, right? Something you can sit on. That's a nice broad rule. I have a 3-year-old nephew who definitely believes his dad is a chair.
Flat horizontal surface.
It's got to have a flat horizontal surface. Yeah. What else? That's a pretty good set of rules. Go ahead.
I just said it can support weight.
Can support weight. Yep. Based off my comment about my brother being a chair, it's inanimate. Although I've got a comment on that shortly. Cool. We started going into definitions already, so we're going to come back to the chair thing a little bit in just a moment while you ponder those rules a little bit more. But if we wanted to like put some tight descriptions around these, feel free to read through these. But again, the idea is that you create a supervised machine learning model by giving examples, by prior experience. One of the most common ways to think about this is, if you throw a ball to a child, and that child has never, they're a 3-year-old, they've never seen a ball travel through the air. The most likely scenario, the first time you throw that, let's say a baseball to them, is what?
Hits him in the face.
It's going to hit him in the face. It's going to hit him in the face. And over their lifetime, maybe they're interested in baseball. They've learned how gravity works. They've caught a baseball thousands of times. We call that practice. That practice is, each one of those is a data point. And for us, it takes a lifetime, to acquire all that information. For a supervised machine learning model, it would take those data points and learn it very quickly. Again, unsupervised is for pattern detection, is pattern detection with minimal human supervision. You don't necessarily need a labeled data set. And then reinforcement learning, again, is you get a reward, or in some cases, like you kill that particular model if it failed to progress, and you run that simulation billions of times. Reinforcement learning is how the chess playing AI learned how to play chess. It essentially played billions of simulated games, more games than any human could ever play in their entire life. So you might have thought of a few more rules, but rule systems aren't particularly robust. There are lots of chairs here that may have conformed to the rules that you specified, but unlikely, right? Like that hand-foot chair, I guess you can sit on it, like it's not necessarily flat, but the most egregious examples are from different angles, right? These different angles of chairs, while your rules may have been able to pick up on it based off of the shape of the chair, if you fed this image based off of that rule to a machine, it can't turn it in 3-dimensional space, right? So your rule wouldn't necessarily address it. So what we have to do in supervised machine learning is teach it just like we would teach a child, right? We would show lots and lots and lots of examples of a chair or not a chair that we have labeled to that particular model. And if we have enough of that labeled data set, that individual or that model will learn generally to some degree of accuracy whether something's a chair or not. And it will never be perfect, because if something is a chair or not is still somewhat subjective to us. Like, is a love seat a chair? Is a couch a chair? How would we actually define those? So one thing to note is that, there's a saying that goes, all models are wrong, some models are useful. And if your model is 100% accurate all the time, you didn't need machine learning for that. You definitely didn't need machine learning for that. Or there is something horribly wrong with your model. So just know that you'll never get to 100% accuracy with any of this, because a lot of this stuff is extremely subjective. Plus, humans aren't 100% accurate at identifying things. Rarely, I think the number is about 89% to 90% of data extraction out of forms is accurate by a human. And you can actually get a model to perform better than that. So I want to get us into our first breakout group. And this is like one of my favorite freaking things in the world. It's a teachable machine. It was done by Google. You are going to, in your breakout group, basically train a machine learning model in real time. So we're going to take about 7 or 8 minutes for this. Nominate one person or volunteer yourself for the breakout group to share your screen. And what you're going to do is follow the prompts on the screen. Now, it does use your camera. So you can't have your Zoom camera on as well as the teachable machine camera. So if you are volunteering to share your screen, you're going to have to turn your camera off so that it can access your camera. And then follow the prompts, and it's pretty self-explanatory. I'm going to drop a link to it here in chat. And I will, Colby, come back and answer that question right after we come back from the breakout group.
All right, I'm going to open up the rooms now.
Cool. You'll see a notification. I'll share this prompt out as well briefly while you guys get situated.
There may be a few people who stepped away for a second. So
that's okay. Always happens.
Yep. I'm gonna go join it. 5.
Hey, Dan, I am unable to share in the breakout room.
Because I'm sharing.
You're sharing. Yeah. All right. Thanks, man.
Yep. You guys completed already?
Yeah, it was cool.
Pretty fun, right?
Yeah, I tried to fool it and I couldn't.
There's some interesting. Did you try raising your other hand?
I did, you know what? But when I did do that, I think I actually raised both hands. So I didn't try the other hand.
Yeah.
So
If you
yeah,
if you train it only with one hand and attempt to raise your other hand, it doesn't perform nearly as well.
right. And I don't think it wasn't looking for, like, I tried raising my hand with objects in my hand. I think it's, it's looking for something in this area. I don't know. I guess that's, the more you train something, the more accurate it's going to be, is what the.
That's what we'll discuss when everyone comes back.
That was very cool, Dan.
It's one of my favorite little fun tools on the internet.
Yeah, I was bragging to Frank. So one of my former students is on the team at the Google Creative Lab that built this.
Oh, cool.
Her face is on you go to the Teachable Machine website. She's the person.
It's up there.
Yeah.
Nice. We can go ahead and close those and give them the 1 minute countdown.
All right, here we go. Oh, we give them 10 seconds here at January.
Oh, only 10 seconds. Wow, that they're gonna have to be in mid conversation when they come back.
Yep, here we go.
Welcome back. Ripped from the safety of your breakout groups into the cold, hard reality that is the main session. My favorite thing in the world is when someone's in mid-discussion, and you guys only get 10 seconds. That's crazy, in the way that this is configured. Normally, we've got a minute, but when someone's in mid-conversation and comes back to the main session, and they're like, and that's why I'll never eat a turkey sandwich again. You're like, how did you get on that tangent? So I'd love to hear a little bit about your experience with that. Specifically, what did you learn about the importance of the data that you gave it, which of course was one set of your hand being raised and one set of your hand not being raised?
We were finding middle grounds or edge cases, right? If you kind of put your fingers in the frame or made a fist or held up one finger, it would get thrown off.
Yeah, absolutely. If you did not capture images while capturing things of your hand up, well, we might say my hand is up right now, but if you did not capture these edge cases, it's going to get confused, right? It's not going to be nearly as confident.
It felt a lot like doing product management work, actually. You're writing a story and you think you've considered everything, and then somebody gives you exactly what you asked for, and you realize oh, no, I didn't think about all the stuff I wanted you to actually.
Yeah, no, I love that. Did any of you record examples with just one hand up and then try your other hand? Couple nods. It's probably a little bit confused. It might have performed okay, but maybe not nearly as good, right? This is my favorite tool to demonstrate the limitations of machine learning models based off of data sets, right? And this is when you hear data scientists and data engineers say, I need more data, I need more data. Well, it's because you have to have data that accurately represents the world that you're trying to mimic for it to be able to make an accurate prediction. Really shortly, we're going to talk about our role as engineers and product people and as designers in this, as I'll have to go a little quickly through it. But our role is important in understanding, well, just what level of accuracy do we need? Can we get that data? Can we help them get that data? As a product manager, as you were saying, what are those edge cases that we actually need to think about? So the data collection and labeling process is it's not a data scientist's job solely. It is a big role that if you're in a product team that you need to share. And I would argue that it's very important for us to get involved in that process. So what do we do as non-developers or data scientists, I should say? Some of us are definitely engineers on this call. What's our role within that process? But one thing that I really want to point out is data science is not software development. Data science is not software development. It's not software development. We got to stop treating it as software development. Data engineering is definitely software development. Data science is a science. It's a science. And sometimes science doesn't work. But our role in it still doesn't really change. We need to understand how it relates to the data science lifecycle and how to think about data science in terms of what we're building. The more things change, the more they stay the same. The product management lens is very applicable to this. It's like infinitely applicable to this. Building a great product is the intersection of desirability, feasibility, and viability. Desirability. Do people want what we built? Is it adding value to them? Viability. Is there a sustainable business model or enough business value in what we're building to make it worthwhile? And feasibility. Do we have the resources to build this? Is it even possible to build this? Do we have the data to build this? And when thinking about data science, like we have to, it's on like all the stakeholders, like it's such a team sport to understand the intersection of this. All you have to do is watch a hilarious video of someone with a Scottish accent asking their Alexa a question to know that Amazon decided that the viability, meaning the cost to extend their model to work for people with Scottish accents, was not worth it at that time. They could have, right? They could have gone out, collected lots of data of people talking with a Scottish accent to better train that model, right? But they, from a feasibility standpoint, probably didn't have that. And they made a product / business decision from a desirability standpoint. It works well enough for them, right? It works well enough. It's fine. It's fine. And in that case, maybe it is fine, right? And maybe they did go back and update it for poor folks with Scottish accents who are just trying to ask their Alexa for directions or to set a timer and it's not working. The consequences on that are fairly low, right? Like if it doesn't work, like you might have a bad user experience for that individual, but the consequences are generally low. So when I think about how to map this to data science questions, we say, well, how well does it need to work? And what are the consequences if it goes wrong? And what are the user experience implications if it goes wrong? So if I have a Tesla Model 3, if my Tesla, predicts very poorly when I put it on autopilot on the highway, the consequences are very high, right? So that model needs a very high degree of accuracy in order for us to find it desirable and even viable, because Tesla can't be constantly sued by crashing cars. But there are big questions around the feasibility of true autopilot today, right? Is there enough data? Colby posed the question in chat: are CAPTCHAs a form of supervised machine learning? Yeah, totally. In fact, CAPTCHAs are a great way to distinguish what contains an image of a stop sign in it. And, I'm sure all of you have done that. That's a machine learning, supervised learning model that has helped train things like autopilot, for self-driving cars. But the consequences, again, of it getting wrong are very high. So we have to make those trade-off decisions. And as designers and product people and engineers, what is the error state when it doesn't know what to do? Well, Tesla has a very good answer for that. If I don't move my steering wheel every so often while it's in autopilot, it screams at me, it beeps at me. If it detects that it's outside of its confidence interval, meaning it's not confident that it's detecting a line or a vehicle, it screams at me to take the wheel. So it's built in human in the loop processes to address for that. So what does that process look like? Well, it starts with obviously a business question. So many times this is where it fails because poor data scientists are never involved early enough in the process. Like our role as like product people and people building stuff is to provide enough context to a data scientist to help them make good decisions, right? We need to help them scale good decision making. And they're never involved early enough in this process around what is the true outcome that we're trying to achieve, right? So they've got to get involved in that process early. Then, while this says agile sprints, you cannot expect a data scientist to work within a 2-week period. Data science is a science. It's taking data, it's exploring whether or not there is any kind of predictive capability in that data. And guess what? Oftentimes in science, in fact, most often in science, things don't pan out right. Like there might not be predictive qualities in that data. You might not actually have the right data set that you can make a good decision from. And that's a big part of it. So I found that forcing a data scientist to work in that capacity on a 2-week sprint doesn't make a whole lot of sense. I often would move their sprint cycle to about a month-long sprint. And their definition of done, as I integrated them into the cycle, was we would start with what experiments are you trying to run during this time period? What's your hypothesis, versus what you were working on previously? And then, at the end of that, what's the state of that experiment? And that's really all you can do in these early stages before you're ready to actually truly evaluate and deploy the model. So data exploration is a big part of it. Feature engineering is determining what actually in the data is driving predictive quality. Then they actually build the model. This is where the intersection of computer science and stats come into play. Evaluate whether that model is performing against your achieved outcome. And finally, getting it deployed, which is typically in engineering or data engineering feat, which is how do we link up what was built in Python into a Docker container with a set of endpoints. And then model monitoring is extremely important after it's been deployed. There's something called model drift. Models change over time. Data changes over time. It might stop performing and meeting the outcome that you expected it to. To set expectations, and I started to do this already, an average model will take 9 to 12 months to get into production at large organizations. And 90% of the time for building that model is in the data exploration and feature engineering part of that. This is why it doesn't necessarily work with agile sprints, because they're literally sitting there running a science project to see if there's any predictive quality in the data and what are the things driving that. So 90% of that time is in data exploration and feature engineering. Then the actual building of the model doesn't take a whole lot of time. That's just a sprint or two, right? Evaluating it is an ongoing effort, and deploying it has been typically very difficult. I find that most data scientists are literally not trained in the way to deploy this, but that's why we have data engineers and engineering teams. So that's typically where a handoff would happen. So our role in all of this is bring that data scientist in early, provide them context, make sure that we understand the outcome, and treat data scientists like scientists, right? Understand that the way that they have to build things does not fit neatly into agile sprints, and that we need to find better ways of working to figure out how the software development lifecycle meets their lifecycle. Another role, getting back to viability, desirability, and feasibility, is really in helping them understand those data challenges like we talked about, the edge cases, right? Do we need representative data? So come off mute or type your answers into chat. We want to build a model that automatically extracts information out of receipts. And we want to be able to give that model lots of receipts to look at. So what does a good receipt look like? Like as a product person, I want to be able to create a well-performing model. What do I need to give that model from a receipt standpoint?
I'd imagine you'd want a certain amount of clarity in the image, not a super blurry image. Also, the format of the image would matter, I'd imagine, on whether the model can even interpret the data.
Yep, clear receipts, a set of clear receipts, that are formatted appropriately. What else?
I guess on that note though, like, wouldn't you also want a bunch of crinkly, crappy receipts with like blurry ink and how they usually end up looking once you pull them out of your purse or wallet or whatever?
That too. Yes. Because receipts are, like kept in wallets for weeks at an end or crumpled up and put in your pocket. You need a combination of both, right? You need a combination of both because you want your model to be able to work within the bounds of reality. And you know who is close to our end user and understands their behavior and understands like if I'm not picking on data scientists. Plenty of data scientists would be like, I need a representative set of reality. But like, I'm a product manager. I'm very close to my user. I understand their behavior. In this case, we're all, bundlers up of receipts, but that's how reality is. We need a set of images that represent reality that we can extract from, but we also need a set of images that like act as a nice baseline for the model, nice and clear images. But most importantly, we need that. What does reality look like today, right? So as we are close to our user base, as designers, product people working on a product team, we have to decide what that representative data looks like. And to what extent between desirability, feasibility, and viability does that model need to be accurate? Does it need to be, accuracy is kind of a loaded term within data science, by the way, but like 80% accurate? Does it need to extract correct information out of receipts 80% of the time? Is that providing value to our end user? Is it not? We have to make those decisions. Those are business decisions. And we need to work very closely with the data science team to help them understand that threshold. Because very typically, to get a model, and by the way, these are just ballparks for illustrative purposes, but to get a model to 80% might take 6 months. But to get a model to 83%, 3% better might take another 6 months. It gets exponentially more difficult the closer to 100% accuracy you get. So we have to decide the trade-off. Is that 6 months worth it or not? Thoughts or questions on this? I've got 12 minutes left, and we've got one more little fun exercise. Cool. So I'm going to breeze through this so I can get you just into the last exercise. But I'd love to hear, while I go through this, some thoughts on like how AI is probably changing your industry. I'm sure it is. It's changing every industry. But let's take a look at a couple examples here and just ways that it's working today. So where are we? Like, there's some barriers to implementation. A lot of this is like regulatory fear or fear that, we can't quantify the risks that come with it. But the biggest challenge, as mentioned, is like data scope and quality. It's the data problem. Do I have the data to be able to create this model? That's changing. There's so much data now available. And this is why we came out of the AI winter, because we're capturing everything. And Google released 360,000 open source data sets. You can go to Kaggle and access a bunch of data sets for free. There's tons of data out there. It's not necessarily labeled or good data, but this is changing the full scope and data quality problem. But still, you have to have that data that's representative for your model. In marketing, we're seeing all sorts of stuff, some of which you already mentioned. Recommendation models is a big thing. User clustering, pricing optimization models, propensity models, things that can, detect whether or not where someone is in their customer journey and serve them up a different button. Basic personalization questions. I've seen case studies that have indicated like detecting where someone is in their journey and simply changing button text from learn more to buy now based off of where that is can provide $1 million uplift, like legit. Intuit did that very same thing for their QuickBooks homepage. Finance, where I was with BCG and State Street, some pretty cool stuff happening here. Biggest thing is like fraud detection. If anyone had solved how to algorithmically predict the stock market, that would have been big news. I get that question all the time. It's very difficult and probably not truly possible yet today. But you can, use it to detect whether or not someone would be a good person to give a loan to. Will they default on that loan based off of characteristics? In the case of like fraud detection, one of the reasons why this is so important that this is a supervised plus unsupervised machine learning model is that there are so many transactions going through that if a human were trying to look at this data set, it would be like trying to read 250,000 copies of the Titanic basically every day. It's impossible. There's too much data for a fleet of humans to go through. So you have to have machine learning models to actually detect this information. Healthcare, I think we mentioned a couple interesting things, but like there's a lot happening in here. Protein folding was brought up. That is going to literally it's not yet, but it's going to revolutionize medicine. If you're curious about it, message me. I'll share some articles on it. It's very cool. My co-founder got his start in bioinformatics and worked on this problem 15 years ago in AI. It was amazing. A really fantastic application of it in healthcare is where you've got a combination of AI plus a human in the loop, where apparently patients in a hospital, sepsis or blood poisoning is a very, very high risk of death for patients who have extended stays in hospitals. And there are now AI models that can predict whether or not someone is more susceptible to getting septic, and it will flag that to the nurse. The nurse will check more often. And that's literally saving thousands and thousands of lives today where it's been implemented, which is very cool. At the very early days of the pandemic, when we didn't have testing for some reason, I don't know why we didn't have that, but that didn't exist. But some cool data scientists and engineers took it upon themselves to build a big neural net that could take a chest X-ray. And basically, they trained it to say, does this person have COVID or not? And flag it in the X-ray. Humans couldn't really tell the difference at that time. But this model was able to very, very accurately, based off of what it saw within the chest, predict whether or not someone had COVID. Then they open sourced the project, and this was, I wouldn't say widely used, but it was put in place at a number of places where they actually were trying to detect whether someone had COVID pre-testing. Many of you at Giant Machines or in other places that do design or build cool things are going to be affected by DALL-E. Raise your hand. Has anyone heard of DALL-E? Cool. So DALL-E, for those of you who don't know, is really cool. I have access to the full DALL-E. DALL-E is a machine learning model that allows you to enter text and it will create images for you. So I was on the waiting list for the true DALL-E for over 6 months, and I got access to it a few weeks ago. So this is the true DALL-E created by OpenAI. So I typed in the words, "a data scientist in space in the style of corporate art," and it produced these images for me. You can produce really bizarre things, and it's very, very good at creating them. It's really, really cool. And you can even go in and like click into one of these. I think this one's particularly interesting. And we can now create variations of it in this same style. So I'll go ahead and click that variations button. The speed at which it's doing this, by the way, is actually pretty remarkable. Manny, you asked, is there a way to calculate the ratio between time and accuracy? Not directly, but to understand that, you also have to understand what we mean by accuracy, like, which again is a loaded term, because you might have a model that you have to start getting into things like the confusion matrix and how many, did it miss things? Did it pick up extra things? So there kind of is, but not an easy way. But look at this. Look at this. How cool is this? You probably won't be able to go get access to DALL-E right now, but I encourage you to sign up. But what you can do is use a mini, not so good version of it called DALL-E Mini. What I'd like to do is get you back into your breakout groups. We only have a couple minutes, so like play around with it for 4 minutes. And then I'd love to have a discussion, a short one, about how you think, based off what I showed you here, DALL-E might affect your world. So I'm going to drop the link to the version of DALL-E Mini that you can access in Hugging Face. It's pretty slow, but then give it a text prompt, see what it creates for you. It's still pretty good. And you're welcome. I just ruined your productivity for the day by showing you access to this. So let's go ahead and open those rooms. I dropped that into chat, and we'll come back, discuss about how this might affect your industry. All right, welcome back, welcome back. In the last little 30 seconds that we have, first of all, were any of you able to successfully get it to run in that short amount of time? Yeah? What was some of the prompts that you gave it?
Space art, AI bots take over the world.
Yes, corgis running in a race. Yeah, Dolly Mini is not nearly as good as the full Dolly that I have access to, and it falls deeply into the sometimes very disturbing, right, cursed image category. Sometimes it produces very cool things though. Faces get distorted, particularly of actual real people. It does not understand the concept of what a person is, right? It's just looking at pixels. It's a statistics, right? It's putting pixels together. But how is this ultimately going to, a lot of us are in a creative field, affect what we do?
Again,
Well, I was
maybe-
mentioning. Oh, go for it.
I was gonna say it can maybe help incubate ideas or expand. If you have a, you know, the beginnings of something that you want to do, AI can help you conceptualize and build that idea into something like real, or just even expand upon it.
Yeah, I love that. A jumping off point for creativity, right? Anything else?
I was wondering how it might be utilized in like the user research world, which is like in an insanely inefficient world in terms of like product teams everywhere reproducing similar types of questions, right? Yeah.
The speed at which you could create variations for that is very high, right? And like ad optimization too. Manny.
I was mentioning in my chat that I had run into a resource that talked about how this potentially could replace web designers if you just type in kind of what you want in a website, and then it'll just kind of auto-generate the code necessary to make it. So yeah.
Yeah.
Isn't that something that's actually available right now? There's a model, I don't know if it's Dolly or something, but you can type in, I want a website with blue font and etc., and it will create it.
Yep, that exists today. In fact, GitHub actually got a lot. You guys might know a lot about this as well. Like GitHub got some flack recently for creating some an AI-assisted programming tool within GitHub. But you can use a combination of so Dolly, GPT-3 can write code based off of how you describe it, and it can use that code then to feed into something like Dolly to create actual web pages. You know, it's pretty amazing. Marcia.
I was wondering actually about the diversity in the industry and how that could possibly negatively impact certain races or groups within society.
Oh boy. I sit on within groups for numerous AI ethics boards, and we've got some deep AI ethics practices at Gravity AI. Our AI ethicist was the former AI ethicist for the UK government. This is an area of deep importance to me. The short answer is that there's an extreme risk within this field, not just Dolly, of very bad outcomes for disenfranchised and protected classes. You know, I give a whole section. By the way, we're over time. I'm happy to stay on a couple extra minutes and talk about this, but I have a whole. I've dedicated hours to this in presentations before. So there's a couple types of bias that happen that eke into models. So there's mathematical bias or algorithmic bias, and this is on us as developers and data scientists to try to work to understand. So what algorithmic bias is we don't have representative enough data. So a lot of the big platforms like Amazon, Microsoft, others have moved away from face detection AI because a lot of it did very poor jobs at detecting darker skinned faces, and particularly darker female skinned faces. And this wasn't necessarily like intentional racism on the part of them. They just didn't have enough representative images in that data set for those individuals. But there's another total flaw within the development cycle that should have been caught. And as a bunch of developers here, after you build something, what happens next?
That's a good question.
Before anything goes into production, what has to happen?
You test it. You have to have a lot of testing.
QA, right? So I suspect in this particular case, like most QAs, they went and ran the test themselves. So if you have a facial recognition software and you're QAing this mostly on yourself, and your QA is a white dude, they're going to go, this works freaking great, pass, you know? So there's a whole slew of like failures into how that might come to happen, right? So this is why you need diverse teams in general to be able to address a lot of these. That type of bias is something that us as product teams should be very aware of. We should all if we're working with a data scientist, have an AI ethicist. There's another type of bias that's much more difficult to deal with. What happens? So in the case of that facial recognition software, we had non-representative data. It didn't represent reality well enough. What happens when you have very representative data, like a true, like, let's say perfect data set, which doesn't exist, but you have perfect data, and it's society that is biased. The bias is inherent because we're assholes, and it existed in that data set. Let me give you an example. This is a real example. We've long known that there has been systemic racism in the housing field, right? Redlining. And if you pull historical housing data to try to train a model to predict who should get a mortgage or housing prices, there is inherent societal bias in that data. How do you deal with that? So there are data science techniques to deal with that, but there's other things that you need to take into consideration, right? Like, and this is why you probably need an AI ethicist. Some very well-meaning people created a data set of housing data. They went out and captured ethnicity and gender in this data set with the best of intentions of using it to help combat the societal systemic racism in that data set. That data set was used for nefarious purposes. It was acquired by somebody else and was used very poorly in the 70s and 80s. And then it was very discovered, right? Like, so this is why you need an ethicist. Should they have created that data set? I don't know. They were well-intentioned. They used it to try to get out systemic racism out of housing market data, but it turned into being used in the opposite way. So I don't have the answers for that, but there are a lot of smart people and groups working to try to solve these problems. So we're way over time. Thank you for sticking on with me. I have stand up right now. Feel free to connect with me. I've got like hours of content I could share with you. Please fill out the survey and let us know how this was. And have a great rest of your day.
Thanks so much, Dan. This was amazing.